This begins to make a set of triangles. See these triangles in here? These are the central angles of those if we do have two tetrahedra inside of a square, of a cube, to giving it shape. The central angles, those are the angles in here. And those angles, interestingly enough, from the 60 degrees that was outside in the vector equilibrium and 70, essentially of 54, 44, 70, 32, I found with the next one, what were the inside angles become the outside angles, and the outside angles become the inside angles. As there was a succession of the great circling, things inside out. So the surface angles become central angles, central angles become surface angles. So I found the hierarchy of this kind of intertransformation going on. Now, I'm going to seemingly switch a little bit here with you now and go into number. So I've been talking about the geometry and we're using numbers, but I came also, I've paid a lot of attention in my life to things that often are not too well thought. I would say astrology. I haven't done as much to astrology because but I would reckon there's something that makes astrology highly creditable, and so many people get interested. Simply taking women's menstruation, which is the very word monthly, which the word month comes from moon. That is discovering the tides of our Earth and the absolute connection of the tides of the Earth and the moon and the months and the months. I was quite. There are tides in women. And this is perfectly clearly demonstration of the being astronomical effects on human beings on planets. That seemed to me to be implicit. Therefore, I would say I think that the people who have done astrology have gotten into too much of the myths that go along with constellations and what constellations are supposed to do in the great azimuth. That what twins do and what I don't think that is very valid, particularly as I began to find these stars are enormous distance, one behind the other, weren't even the same constellation, but from where you and I happen to sit, we've got that appearance. So that we were taking a blackboard effect where there was not really such a cartoon in the sky. So I felt that there were too many stories came in there to make me have time to really fathom. I would like to get to be a great astronomer. I'd like to know much more about this. I'd like to be able to use the planetarium to advance, but also take the real distances of two stars and so forth and see what would be the ones that were really having some force in at that time. I think something like that could be done. But the point is, big thing is that I will not dismiss something that my intuition has given me any clue that there could be this has good reasons to exist. So much superstitions and so forth. Obviously, walking under a ladder is a pretty stupid thing because people are always working on ladders. That's why there's a ladder there. They're allowed to get something in their head. I think that's a fairly good probability one. But I pay attention to all the superstitions I've been told about on the basis I might someday learn something. And one of the things that really impressed me a whole lot when I was young was numerology. I don't know how many of you ever played games of numerology, but there are where you take then the letters of the alphabet and give them their numbers, and you discover some very interesting kinds of combinations of things that happen. And I was interested enough in numerology to really begin to try things out in a mathematical manner. And I'm going to tell you something about that now tonight. First place, we have human beings counting in tens, which is a fairly logical way. You can see you had 5 fingers and 5 fingers counting on your hands. There are, however, other people who have counted in 12s. And 12 is a very convenient way to count because the count in your hands, the decimal doesn't even include the number 3, and just there are going to be a lot of triangles in the world, and and any time the 3 comes in, it's not going to, the number's not going to come out evenly, the calculation. So that, but it seemed that the people who liked the 12 had a very good reason to have it in there. But the 12 itself didn't include the 5, so that maybe when you got to some other kind of module would be better. And then there are, if you just think about the single integers, you have the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you did even get into that's the 60 degrees, which is comfortable, that prime number 1, prime number 2, and prime number 5, and then prime number 3. Multiply 1 times 2 is 2, times 5 is 10, times 3 is 30. So if you get the number 30 and the number 16, you're going to be able to accommodate the first 4 primes. But it does not accommodate the prime number 7. So when we get into trigonometry using 60 degrees and 60 minutes and so forth, every time the prime number 7 shows up, any division will never come out even. It just automatically throws waves of error into systems. I saw that, very interesting, that it was Plato tried multiplying the 7 quite clearly because they're in the notes, but he never talked about it. 7 times for instance, 7 times 360 degrees gives you would somebody do that? I think it's 50-40, isn't it? 25-20. 25-20. To come out 25-20? Try it. So 25-20 was an interesting number because there could be 5-0, 4-0, 4-0. So, but Plato has, you can see that he wrote about 25-20, which made clear he was trying to possibly bring in the prime number 7 into accommodation in trigonometry. Those kind of thoughts also then appeal to me when I'm trying to find, I've been looking for nature's own comprehensive coordinate system. That's what I was after, if I could possibly find it. And therefore certainly it was going to involve number. So I've had to pay quite a lot of attention to number. Then I saw that I'm going to give you something really quite interesting. We'll do a little counting here. And this is the way we've organized ourselves in decimal system. We think that's great. Now, in the game of numerology, where you give, what they do is to take numbers. You give a number for a name, and you add your integers. And if you get to more than 10, you go, for instance, that 11 is a 2. And you simply integrate the integers. And if you did that, for instance, in the way we count numbers here, this would be a 1, and 1 and 1 make 2. So I'm going to use another color. So this would be a 2, and this would be a 3. This would be a 2, and this is a 3, and this is a 4. 3, 1 and 3 is 4. This is a 5. 1, 4, 5, 6, 6, 7, 7, 8. This would be 8 and 9. And this would be 1 and 8 would be a 9. And this is 2 and 8 is 10. This would be a 1. And 1, 9, 10, that's a 1, and 2 and 9 is 11, that'd be a 2. And this would be 2 and 3, no, that's that. 2 Yes, this is a 2, and this is a 3. So we got, things are not coming out, it's gaining all the time. So I tried doing counting in 11s, and I tried counting in 9s, and counting in 8s. I found that, let me just try the 9 now. Jimmy. So this one is a 1, and this is a 1, this is a 1, 9, 10, this is a 1. Sure. 1, 1, 1. 2, 2, 2. 3, 3, 3. 4, 4, 4. 5, 5, 6, 6, 6. 7, 7, 7. 8, 8, 8. 9, 9, 9. That's very nice because it's neither gaining nor losing. And if I tried it in 8s, I find it loses 1. And if I try it in 7s, it loses 2. If I try it in 6s, it loses 3. If I try it in 5s, it loses 4. Then I tried it in 4, and it gains 5. And I try it I'm going wrong. This is all this is still in trying in 8s. It was always losing. It says the 5. If I did it in 4s, it lost 5. 3s, it lost 6. No, it doesn't. Excuse me. I'm wrong about that. 4 lost 1. 4 lost 4, that's it. 4 lost 4, 3 lost 3, 2 lost 2, and 1 lost 1. It was a very interesting one where there seemed to be plus and minus numbers going on here. So that this one seemed to be the most satisfactory. This is the only one that didn't gain or lose. That seemed to be commended in a very important way. In other words, I then found that when you're doing this way, that there was a 1, there was the continual balance where 1 obviously gives you plus 1, 2 gives you plus 2, and 3 gives you plus 3, and 4 gave me plus 4, but 5 gave me a minus 4, and 6 gave me a minus 3, and a 7 gave me minus 2, and 8 gave me minus 1. And then there's a 9 gave you 0. This is interesting. There seem to be sort of positive and negative 4s that are going on here as an effect. But the 9 had a 0 effect. Now the 9 having a 0 effect was something well known. When my first jobs in business before World War I, when I had an accounting job after being becoming a mechanic, and in this accounting job it was in a big packing house, Armour Company, and they had on the meat markets of New York, the wholesale markets, and enormous amounts of foods were being shipped into New York. So the accounting, keeping track of cutting up foods and everything, was a very powerful job for the branch houses. And the auditors came around quite frequently, and the auditors taught me a trick of theirs, which they called out casting out 9s. As Somebody give me 3 or 4 numbers. I'm going to make a multiplication. Just give me random. You start there.
7.
You're going loud with it?
7.
7.
4.
4. What next?
15.
No, it was a single integer.
9.
9.
Somebody else.
1.
2. No. Who said 1? 1. And you wanted the 2. Right. So now give me a multiplier.
3.
She very sound. 5. 3. And somebody else.
2.
Good and loud.
2.
2.
8.
8. Who said 8? Right. I would just try a little multiplying here. 8 times 2, 16, and 1, 9. 9 times 8, 72, and 8 times 4, 32, and 7 is 39. Carry 3. Check me, will you, all the way through, please? 8 times 7, 56, and 3, 59. Is that right? 2 times 2 is 4, 2, 18, 9, 14. 3 times 2 is 6, 3, 7, 14, 22. 5 times 2, nothing. 7. Oh, excuse me. 5 2 is 10. Carry the 1. 6. 6. Anybody find it follow me? Anybody find the error? Okay. Now, here's where these auditors do. They say you cast out all the 9s. Keep looking for red, and I put the wrong thing. Here's a 9 right away. A 7 and a 2 make a 9. So all that's left is a 1 and a 4. That makes a number over here we call 5. And I get in the 9s, and here 5 and 3, 8. None of those combine to 9, do they? So 5 and 3 is 8, 10, 18. 1 and 8 makes a 9. Well, they did make a 9. 8 and 2, 10, 13. No, it's 19, isn't it? Come back at 8, 10, 18. And 1 and 8 is a 9. So apparently going to do that. Now down in my summary, I have a 9 and a 9. And a 3 and a 6 make a 9. 3, 4, 5, 6, and 3 makes 9. There's nothing here. So this is a 0. 9 is a 0, so 0 times 5 is 0. Right? It is a 0. This way they did. So what they would do is to cast out these 9s in the input and the answer, and they could tell very quickly whether you made an error. Now, the fact that human beings, and this apparently been known for a very, very long time, and the more I thought about it, the more fascinated I became, because quite clearly the name 9 in our English and Latin, none, and in German, 9, these all mean no, 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 0. In other words, it must have been known a very long time, because I also said to you the names for the numbers are amongst, in etymology, amongst the old names. The old, nobody knows what they stand for, but it's suddenly that you'd find that the 9 is associated with the noneness. This must have been long while ago. And again, I always suspicious around my number world, my geometrical world, because of the realization that the navigators did then hold the great secrets, and the king respected them fantastically. He didn't know whether so the priest was always being able to give the emperor king something very tricky, and he absolutely guarded his mathematical capability. I don't think there's any question about this, and then it keeps showing up. Anyway, this then began to tell me nature had a way of counting here, which is really pretty interesting, where might have really do have a 0 level. This is 0, and then she has a +1 and a +2 and a +3 and a +4. Then she drops right down to -4, -1, -2, -3, -4. So that she seems to have a system going here of 1, 2, 3, 4. Then she drops right down to -4, -3, -2, -4, -3, -2, -1, 0. This being a 0. And she seems to then keep this one will go on like that and go on like that. But there's a connection like this. There seems to be a wave phenomenon. This could even double back on itself, just make a bow tie out of it. Because it could look like this. That's what it looks like. And that is part of a great wave system, where you simply have these bow ties. So, I think she's using, and I think nature's very definitely using this. This is a number itself. And give me the +4 and the -4. That again sounds very familiar, along with the tetrahedron traces and with the octant accounting and so forth. That's all there is. These are all the faces and all the characters there are. And I'm quite sure this number must relate very much then to the way, what are all the variables of the system. And there are only 4 positive and 4 negative every time. I find very, very exciting. That's why I said this octant had then great appeal to me when I came to realize the coupler was an octahedron that had these really all the variables were in it completely. In relation to what I've been saying to you and talking about prime numbers, I'm going to give Mehdi a check to look at. Somewhere in the back here, Mehdi, there's a sheet of paper which I'm not allowed to look at right now. There it is.
Want me to write it on the board?
This one, that bluey. No, you keep it to yourself. I began to find some very extraordinary things going on in numbers. I began to explore more and more and more. You just sit down and keep it to yourself. And saying I was interested in accommodating. If we're dealing in octants, then just mathematically, I don't know whether how much you've looked at trigonometric tables and so forth, your sines and cosines, but if the complementary of the sine is the cosine, and the two together have to keep adding up to 90. So, let's get to a quadrant with this right angle like that. It's an isosceles triangle with 90 degrees. And this is 45, and this is 45. Any other triangle where it's 90 degrees, but say it's a 60, 30, 90. So 30 and 60, either 90 and so forth, they're complementaries. But I say you can look at one column or the other column for the sine and the cosine because these things are exchanged. So the largest number you can get to on the small side is 45. From there on, this is the biggest one. Then you can always just find out in the terms of the small number. And the tables are right there, and it simply matters whether you want to use the positive side or the negative, whether you go cosine or sine. So now, this made it very interesting. I said then, if I wanted to really accommodate all of nature's transformings, I really have to have all the prime numbers up to the number 45, or else the calculations will come out badly. I need to have a comprehensive dividend that will accommodate all those prime numbers. And it probably ought to have quite a few of some of those prime numbers, because a 2 will show up quite a lot. So I have such a number, and the Mehdi has it there, and I call it the Scheherazade number because I'll explain that to you in just a little bit. Or maybe it'd be fun to see why it's Scheherazade first. I want you to take the prime numbers that are not included. If we're going up to, I've got a positive octave and a negative octave in an octave, in an octahedron. I've got to have both the positive and the negative. I've got the positive side has a 4, and then the other side. So 16, I like all the prime numbers up to 16, or possibly all the prime numbers up to, maybe up to 18. But let's say up to 16, which takes 2 octaves. So there'd be prime number 7 has been left out, and 11 and 30. 7, 11, and 13, anybody tells you those are very bad numbers. That's crap numbers, and everybody knows to be avoided. 13 is an absolutely awful number. So I want to see, if we take these numbers, which the myth makers of the great priesthood made very, very bad number. I want you to multiply 7 times 11, very nice, 77 times 13. 21, 3, 7, 21, 23, 77, 1, 0, 2, 3, 0, 1. Very interesting number, 1001. Now you know why I talk about Scheherazade. Scheherazade, remember, had the 1001 Arabian Nights tales, where she kept telling them stories. This is not great Arabia, where the Arabic numerals are the big story. And I say, let's try, multiply 1001 by 1001. We get 1001, and get a 0, and another 0, and then we get 1001 again. This makes a very interesting kind of number. 1, 0, 0, 2, 0, 0, 1. It's almost like a binomial. There's a squared plus 2ab is b squared. There's a 2 in the middle. 1, 0, 0, 2, 0, 0, 1. It's a beautiful symmetry. It's a lovely number, isn't it? Let's try multiply it 1001 again. So we get 1002, 001 by 1001. So we get 1002, 0001. Then you move over 1 place, 2 places. Now 1 times, so it goes to 1, 0, 0, 2, 0, 0, 1. So we get 1, 0, 0, 3, 0, 0, 3, 0, 0, 1. Always coming out mirror. Every time is a mirror. This goes on and on and on. This most extraordinary thing, because suddenly introduces symmetry into number. Now, what do they call that 1001? They didn't want anybody to know about those lovely numbers, and makes some very, very extraordinary things. So I find that, for instance, if you want to just take 1 times 2 times 3 times 5, which gives us then the 3 to 1 to 2 is 2 to 3 is 6, and 5 is the 30. Then let's get the second power of 30. So that'd be 900. So I'd like to take the second power of the first 4 primes times the second power of the next 3, and you find you're multiplying the 900 times this number, and you find it comes out again a beautiful symmetry number. In other words, and I'm getting a whole lot of prime numbers in here, and it's highly rememberable, what I call sublimely rememberable numbers. They're so symmetrical that you cannot help it, and they actually build up to the center and down the lovely hill. So I found that I found a whole series. I went on into really large numbers because I wanted to thought maybe I have to have more 17s and so forth, and I began to get into all the prime numbers up to 45, which is, and I have this rememberable number. And I've got to prove it because Mehdi has it over there, and it's I'm not going to have room for it all in this 6. 2, 6, 3, 0, 3. How's it? I'll say to you very fast: 312-858-158, 319-499-960-973, 208. 642-615-613-036, 8 million. And read what that number is, but let me have it Mehdi here. You know, the multiplication is simply a dot between the numbers, right? Not decimal. So this is 1 to the nth power, of course, and 2 to the 12th power. It is 3 to the 8th power, 5 to the 6th power, times 7 to the 6th power, times 11 to the 6th power, times 13 to the 6th power, times 17 to the 2nd power, times 19, times 23, times 29, times 31, times 37, times 41, times 43. So it has a very large number of the the first 1, 2, 3, 4, 5, 6, 7. The first 8 is very highly accommodating, so forth. So that I'm quite confident this number used as if we use this for the circle, or we could even just make it 4 times this number and make it for just one quadrant. One of the interesting things, this number is a very big number. I want you to take how many places are. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43. It'd be 3 times 10 to the 42nd power. It's a big number. This number is so big. It's interesting that Eddington at one time, Sir James Jeans came out of this number as possibly the most adequate number in the universe. If you take using the diameter of the nucleus of the atom as length, and that is a very, I've forgotten what it is in relation to the diameter of the electron. I'm talking about the nucleus versus the electron is about something like 10, I think it's 10,000 times with electron. So this is a very small number. If I then express the distance, the large radius of our observation astronomically so far, which is 11.5 billion light years, and multiply that, put that into light to miles, and then keep making that rate down. If I express then this largest measurement in the terms of the diameter of the nucleus of the atom, this number is so I can take it down to 10,000ths of that size. It's that big. I just want to really what an extraordinary accommodating number it is. And we find then, as we get into the electron microscopes, we're really finally getting into knowing something about them. When the first picture they ever took of atoms per se, where you could see them, not one atom, but atoms, they had the a needle point, a tungsten needle point, and you could see the shape all right, but it consisted of oranges stacked up. They were little spheres. And they would take it out, and they would polish it and just rub it, and they'd put it back in. They kept doing it, but it was always whole oranges. You could not fractionate one of the little spheres within close to packing. Nature always does it in whole atom numbers. She plays the game in whole numbers. That's why your chemistry comes out that way. So I felt that you had to really find a comprehensive quotient that would permit everything to come out absolutely whole number. And this number is big enough to do that, really. So I find it very exciting. I'm giving you more and more evidence the way I try to look at things, but I must deal with some totally in both in my countings and looking for the coordination of nature itself and what are the tools we'll have to employ. And all these things are in synergetics and in really great depth. I show you there. 900 pages in synergetics. So the kind of things I've been talking about, we really get out and we get out and get out. And I'm hoping that we may be able to get some advanced copies for all of you, so that you really can keep on, because I hope you'll like what we're talking about enough to want to go on and make models and possibly improve our picture that we have here, because I think we do really have a very important tool for our fellow men in this kind of a meeting that we're having, where I'm really checking with the young world. You have your experience and a lot of information, and I'm quite confident that I'm not misleading you and that you're able to see how much that agrees with experience you've had and information you have, and find out whether this is reasonable, because I'm really submitting to you a completely different world from the world the way of accounting that human beings have been employing all the way through. I find it very interesting, again, go to Tobias Danzig's book on Number, the Language of Science, to note then the different languages and what they use for quite clearly for their counting system, and where they had a name for the number, they had a name for higher numbers than our number 10, where we have to say, we say 11 and 12. So that 12, 13 is a 3 and 10, but 12 is a word by itself. So we could say the very word svils. These languages that have named 12, but were people who did include a 3 long ago, thinking that that'd be better. So they got into dozens, and you find the French getting up to 16. So you don't say and 7 till you say 17. So I find these would be cardinal numbers. So the different languages had different magnitudes, and I thought very well of the French because there seemed to be the 16 seemed to be 2 octaves, possibly positive and negative octaves. That seemed to be a very, very valid kind of a concept. But you can see that human beings were way back doing a lot of thinking, and these things are manifest in the world of the numbers, which is a very revealing matter. I'm now going to switch again I want also to remind all of you that making my plans for what I can see still has to be talked about. And I made a good inventory today, having gone out 20 hours. I now can see exactly what I'm up against. And I'm assuming questions, that you're all going to be accumulating questions, so that I thought on next Saturday would be the questions. I don't see any use in having questions until we really do submit. So you find many questions you are prone to ask do get answered before you get to the question section. And so that I think it'd be better to have it the last day. So I'm assuming we're going to get quite a little time in next Saturday. We could do 6 hours. I will have some things in reserve if we don't use that up, because I would like to really be sure to get everything possible. I don't think I can get everything in, so I'm going to see what are the priorities, what I left out, and I'll finish. And Saturday we'll stuff those in if there's any time left over. So I'm not going to tend to answer questions. People ask for questions, but I am now going to switch over and going to open up about this chart I gave you. I'd like to get back more to the little human being, really, so you can understand with me how I happened to really peel off that this is not noble. It was really the only thing to be done. I actually got to a moment where I was either going to do away with myself or do something like this. And I'd like to get into the strategies that I employ for how the little individual can be effective. Certainly when the little individual tackles this, just finding out about number, these are very powerful tools. And you understand that by looking at big patterns, I get synergetic effects that I would never be able to get if I went at things myopically. So our society, with all its specialization, was just tending to exclude rather than to include. And the more I included, the more chance I could see in the connections. And really, might really find something of very great power for man. Now, I've given you the grand strategies of great navies, the grand strategies of old city-state, and that is replaced by the line of supply, and then this gets into it goes from the water into the air. The water had limits of continents, but the air had no limits. And so that we're in an era where the game of the power structures and of ignorance, that has to be you or me, are being played in a very big way, and they buy the capability to do that with their military mandate. It has to be you or me, therefore we got to get the very best weapons and tools. And so what are you and I as little individuals going to be able to do that really will bring this to a halt? Obviously, if you go out and I stand in front of the railroad train, you don't stop the railroad train. Protesting means nothing to me. Activism, I would simply say, is part of a political game, a psychological warfare playing on try to upset the other kinds of economy. So as far as really stopping anything goes, I don't think it stops anything. I do think it's educational, and everything goes on in the universe, I think, is the way it ought to be. So I think that these things happen, and I credit everything that happened. I'm glad it happened. That's the way it did, but I don't think it gets positive effects. It may stop negatives, but it doesn't make positive. I'm deeply impressed with Mahatma Gandhi's passive resistance, but while it could then really break down the enemy's offensive side, it could not really feed. So it did not produce, it didn't solve the problems of the poverty. So this is why I'm sure that Nehru became very interested. I think I told you about meeting with Mr. Nehru, and did I tell you that? In 1958, I was speaking in New Delhi, and I spoke 3 times in the same day. First on the architects, and then engineers, and then in some I think artists with the third group in the evening. And at all 3 sessions, Mrs. Indira Gandhi, and at the last session, I gave her a tensegrity I'd been introduced to in the first morning session. I was tremendously impressed that she appeared 3 times that day. I gave her a little tensegrity structure to take home, and she said, would it be possible for me to come on Saturday to meet her father, Mr. Nehru? I had been planning to go to see the Taj Mahal on that day, and I said I had been planning to go to the Taj. I'll just not do that. She said, well, if you don't tell my father that you did that, because he doesn't like people who come to India and don't go to see the Taj. And I said I'll see it another time so it makes up for the deficiency. So anyway, we did meet, and when I might as well really tell you a little about this, because I told you about the meeting with Einstein, and these people are very fascinating to meet. Mr. Einstein had extraordinary quality about him. I still don't know how much was psychologically within me, but I really felt very much in the presence, almost an aura of the man. Mr. Nehru came home from the Parliament to see me. I talked to Mr. Gandhi all morning. I had my maps, and we had them out on the floor of the parlor floor there. And then he finally came, and he came to the doorway, and she introduced me to him, and he never came any further than the threshold of the door, the main door of the parlor there. And she said, please explain your philosophy to my father. So I said, I have a strategy which is other than political, and I know how extraordinarily well informed you are in the world of politics. and I explained that I had a policy where, instead of trying to solve problems by political reforms or laws, any reform of man, I was interested in reforming the environment, because the environment itself is continually reforming itself. And I said, there are options, and I can participate in it, and if I can bring about a favorable environment by virtue of producing artifacts. I must never use words. I must actually find a tool that solves the problem, makes what is going on obsolete. As for instance, I gave you the other day a bridge over Roaring Gorge, and people need something on the other side instead of having to keep risking their lives crossing through the Roaring Gorge. So they'll all spontaneously use a bridge. Unless people die, and they'll get what they need more readily. So that I said, this is my strategy, and I felt that it was the objective side of the Nehru's coping with the negative, the subjective side. And I talked to him possibly 20 minutes, 20, 25 minutes. I didn't have my watch out, so I can't tell you, but it seemed to be kind of that magnitude. And he stood all that time like this, facing absolutely straight ahead, not looking at me. There's no way for me to get anything from his eyes. It was very strange to talk to a man standing like that. He was in his beautiful white kurta and hat. And finally, I said, I think I've said it all. And so he just went out. And I met him, of course, later on again. But I was told by other engineers and scientists that he had done that with them. I've not heard that he's doing it with other people. But apparently, when he really wanted to hear you, really cared, this was his discipline of his body. He was absolutely listening. He made it clear. Beautiful white kurta and hat. And finally, I said, I think I've said it all. And so he just went out. And I met him, of course, later on again. But I was told by other engineers and scientists that he had done that with them. I've not heard that he's doing it with other people. But apparently, when he really wanted to hear you, really cared, this was his discipline of his body. He was absolutely listening. He made it clear to me in further meetings he hadn't missed one iota of one word that I said. He had it absolutely straight, clear. It was amazing how this man coming from the parliament know what was going on, all kinds of the political messages of that kind of a life, and to suddenly give himself like this, he really addressed himself to me. After this, Mr. Gandhi said, whenever you come to India, and particularly New Delhi, where their house is, be sure to telephone right away and let us know you're here. And I have done so ever since. And there came a time, there was one meeting we had in Nehru at Lake Kashmir, beautiful place of the Vale of Kashmir, and he'd gone there to rest, and I had a number of things that I had written with me. When I talked to him that day, I said, you just have words, and you're here to rest, so I better stop talking. He said, I like your words. You're a man of very few words, but what he said, you really felt them. And when I was leaving, he took me out. We were way out on the hillside in the car, and they took me into the house, and I was very Krishna Menon was coming to call, and then he introduced me to him. But on the way out, I had these things with me, reprints of magazines. I said, I have with me a number of things that I've written, but I don't believe you have time to read them. He said, I read every word of yours I can get hold of. Now, I say, the very few times did he speak to me, but when he did, he would say something just like that. There came a day when I came to Delhi, and I called up the secretary, Mr. Gandhi, and the secretary called back in just a couple of minutes and said, would I please come right over? And I went over to the Prime Minister's house, and they have a number of little ante-rooms. I found myself in different rooms as I come into those houses. And she came in very quickly, and she was eyes in tears, really. And she said, my father just had a stroke. And you don't, I thought it was very moved that she wanted me to come, but it wasn't if I really knew her well enough to. But on the other hand, she really didn't. She'd been brought up. I want you to think about how she'd been brought up. Her father in prison most of the time, political prisoner, and some of the time she was in prison. And he was all her education. He did all her education from the prison. His book on world history is a very great work on world history. But it was the book he wrote, and it was putting together the letters he wrote to his daughter. She was brought up by him by extraordinary writing. And she'd been Mahatma Gandhi's flower girl, but she'd been in the world of politics all her life, and really didn't have anybody too close in there. She was married, had 2 sons, her husband died. So I said, trying to think what you would say to a lady, the father just had a stroke, great man. I said, if your father were not to recover, or if he were even to die, would you try to carry on his political work? He said, oh, no, I would not think of doing so. I really have no aptitude. I couldn't be more familiar with that world. That's not my world. I mean, my best to be my father's companion and to carry on in that kind of way. But as for taking any political initiative, I don't have it in me at all. This is a very important thing to hear from her under those circumstances. I don't think the question had ever come up. Because later on, when he did recover for a while, he did get back to Parliament, then later on he did die. But when he did die, the Congress Party, which he and others put together, was an extraordinary accomplishment, because England left them, and I gave you divide and conquer, and nothing could have been more divided than India. It was an extraordinary thing to be able to get a party that would really hold together. And he had great genius there. When he died, his political opponents and other ambitious men who would like to take over, so they thought they could carry on fine, but they found they couldn't. Things became quite clear the Congress Party was really going to break up completely. The only thing that could hold together would be just the name, so they asked Indira if she would be willing, pro tem, to be acting prime minister till they had the next election. Something to hold things together, so she said she was willing. And when I heard that she'd done that, I thought about what I had heard her say under those extraordinary conditions. That I possibly the only person in the world that knew that she was not going in there for any political ambition. She was going through absolutely with a dedication to her father and to Mahatma Gandhi, to their philosophy. So she went in as a housekeeper, and she's been in there that way ever since. Every time I go to India, I see her. She usually gives me at least, she likes to have me around an hour or so. And I sat with her as the Pakistan had their first air attack on India at that time. I've been in some very critical moments there. But she'd like to have me there, and she'd like me to really talk about other things. I was asked to give the third Nehru Memorial Lecture, and I can't remember what that year was now. It was certainly half a dozen years ago, possibly 8 years ago. And I've had very interesting experiences in India. Now, that came about by talking about that because I was talking to you about my grand strategy and the idea of developing artifacts. And I saw there's nothing to stop the little individual from developing artifacts, and particularly if you really can see what some of the big problems are. Now, one of the big problems was, quite clearly, I had become excited by my Navy experience and realizing that we were doing more with less, and the more with less of the Navy was what we call high secret. This is most highly classified information in the world. What you could do more with less, more with the same or more with less when it came to contact. And I realized the more with less you got where a little airplane was then sinking a big battleship. And it could be, I said, that the Malthus was really wrong. He didn't know the foods would be preserved. I spoke about that to you the other day. So I also then saw that there was a possibility of doing so much with so little, we might be able to take care of everybody. In the whole raison d'etre of politics themselves, war, weapons would actually be obsolete. This seemed to be something to really shoot for, the little individual, because I saw it was full of soft spots because nobody's ever taken what they call, as weaponry, I invented a word called livingry. Nobody's trying to see what would happen if you took care of livingry because, they said, there's never enough to go around, so money just doesn't get spent that way. It's just useless. It only gets spent in this negative way. Nobody's really said, what do you need for human beings? Nobody's ever spelled it out. So this particularly came then to the weights I knew of buildings. I saw that man was using incredible amounts of material, and that there was no science in it. It was beautiful, skilled craftsmen, but the architect could design the building various shapes, and he had to be fairly well informed. Something about cobbling and so forth, but he did not have to lay the bricks. The craftsman made the thing work out there, following his shape, and he was doing shapes that a client said he wants this way, very, very much, and so I said it is a possibility in the direction of livingry, and particularly in the environment controlling the shell and the equipment that goes in that takes care of our various chemical processes and energy needs. There's possibility this could be really cut down quite far. And so you can understand then, by great luck, getting out of the Navy, which had taught me so much there, I had, first before World War I, I'd been also, when I got out, I went to Harvard, and I was looking forward tremendously to going, and when it all happened, I got into a social nonsense of coming from an expensive preparatory school with very rich boys. My family were not rich at all. My mother and my father was really just able to get me there, just pay the tuition and rent and a very small allowance. And I found myself not being able to join clubs and things like that. But anyway, one reason or another, a love affair that didn't roll right and this and that, I got myself quite unhappy, and I got perfectly good marks, no trouble at all, but I was really feeling I was there for athletics and fellowship and things. I was not gone there with the idea really of getting education. Because I've already made it fairly clear to you my feelings about mathematics, for instance. While I was still in the preparatory school, I was working afternoons when I had to stay in. I had really gotten quite through far into college and university mathematics. When I got to Harvard, I didn't take mathematics at all, because by this time I really caught on to a lot of patterns, and I was pretty sure that I'd be able to, I could just read my own mathematics. I didn't even have to go to, and I assumed that I didn't take the things that I knew a lot about. I took the things that I didn't know about. So I took musical composition and things like that. Anyway, I took government. I wasn't really interested. I had never been interested in government. I took government as a good idea. But anyway, in no time at all, I found myself in pain, and I cut all my mid-year exams, and so they had to expel me. Which was just like a little bit of nonsense in here. I had been quarterback on my football team at my preparatory school, and the quarterback just before me came the Harvard quarterback, and the quarterback before him the Harvard. So I had a good chance, I thought, to be quarterback. I bust my knee. Everything all went to pieces on that. I didn't have that to go on, and many other things seemed to keep coming up. So I certainly wasn't going to be taken in the clubs. I didn't want to be outdone by my friends, and my sister had been married the year that I went to Harvard, and she'd gone on a honeymoon. She had a beautiful Russian wolfhound, and she asked me to take care of it in Cambridge. There was a kennel there, and I found I could do something wonderful. I could take my Russian wolfhound and go to the theater where there's some very popular actress, and I could stay outside the stage door with my Russian wolfhound. She'd always stop, and I could get talking with her and we'd get somewhere. So I would take Mitzi, and I went to the stage door of the Passing Show in 1912, and there was a very attractive girl who was called the premier dancer, and her name was Marilyn Miller. She was unknown at that time. And so I used to take her out, and her hired mother and Mitzi, we'd go with the Russian wolfhound and her hired mother, so we'd have dinner. It was not a very cozy affair, but anyway, she then, her play had tried out in Boston, and it was a success, and they were going off to New York, so this is when the midyears came along, so I simply went down to New York with them, and I took my whole second half year's allowance, and I invited the whole chorus of the Winter Garden out to dinner, and I didn't know what to do with these girls, I assure you, but at least I had them there, and I could really say to my classmates, this is really, I'm really outplaying you altogether here, one-upmanship. I say nothing could be more childish and stupid in a sense, but I really was extraordinarily young and naive at that point in my life. However, this then got me out and got me in learning to be a millwright. I was sent to Canada to work in a cotton mill with some Lancashire Englishmen who were putting up the cotton mill machinery for a brand new factory, a cotton mill. And it was a fascinating experience. And I learned to put up one of each of the different kinds of cotton mill machines myself. And I kept notebooks and so forth, and everybody said, this boy's done so well, Harvard invited me to come back again. So I did go back. And I went through the same thing again, and got out and went down. This time I worked for the packing house, I told you, Armour & Company in New York. And I worked in 28 branch houses of Armour & Company, with the markets open at 3 in the morning, and you work till maybe 5 or 6 o'clock at night. It's a very long day. And I had this experience of pre-morning in New York at all the, going way up in Westchester, everywhere. There are 28 different branch houses over Jersey City. And I really got knowing New York in what feeds it, so it's a very extraordinary experience. And then World War I came along, and I went off in the war, went off in the Navy. But then when the war was over, by then I was regular United States Navy. But then our first child was born just the last year of the war, just at the time of the armistice, and she caught flu, and then infantile paralysis, and then spinal meningitis, and we had a long battle to her. She died just before her 4th birthday. And this is a very, you imagine how we felt about this. And she had been all the more endearing that she couldn't move around. Her little mind and brain, not damaged at all, but unable to move like other children. And she asked, we found her demonstrating this extraordinary capability because she couldn't get out to touch things with her own hands, as every other child wants to. She had to get her information about things through other human beings in the room. And we had 2 trained nurses, first one and the other, and my wife, one of us, be on duty all the time, very often 2 of us in the room together. And this little child was so sensitive to us that we'd be about to say something to each other that would be to do with our grown-up things and not really this little child. And just you had the words all formed on your lips, and she'd say it. You'd look at astonishment. And I began to really realize that all human beings have something in them that once in a while you say, the only way I explain that is telepathy. We all have those experiences. But we've also learned to shun things you can't explain, and that's not scientifically accredited, so it's not well looked upon. But I felt that quite clearly nature has what we call fail-safe alternate circuits, all kinds of alternate capabilities, so that when this thing doesn't work, so we all have this telepathic, but don't usually use it very much. But this little child had nothing else to get her information, so it was highly developed. And this made me accredit telepathy as being something probably in due course we know exactly this ultra high frequency electromagnetics. But for the moment it's inexplicable, I said. And our feelings about this little child were incredible. My wife was the oldest of 10 children. Her mother died the same year our child died, and one of her brothers was killed. It was a very sad year. She then stayed at home with them while looking out, and I went on with an activity that I started in the building world, and both in New York where she was, but mostly I was away, and I had a big operation in Chicago and Boston and Washington and other places. Anyway, we were 5 years of this, and then suddenly our 2nd child was born in 1927. And with being trusted with a new life was a very extraordinary moment. During those interim years, I drank a lot. I worked fantastically hard on what I was doing, but lived a very rough life. And I got to know Al Capone and through his stopping at I had a factory in Joliet, Illinois, and I'd go out there every day from Chicago, and he had a big bar on the way in from Joliet, so I used to stop there. But I've had some very extraordinary kind of experiences in my life, and this was when this new child was born, all this sort of negative, I've been really trying to bury hurt and feelings, and I got really where I'd gotten quite a lot of people that love me, and really a lot of rich young friends who wanted to back me when I went in the building world in 1920. When I came out of I had to resign from the Navy because of the imminent death of my first child, and went back in Armour and Company, and in Armour and Company I became assistant export manager for Armour and Company. And that was a very beautiful big pattern experience. And incidentally, in the Navy, I'd had this big pattern experience where I'd become, after the quick, short course in the Naval Academy, I became aide to Admiral Gleaves, who was in command of the Cruise and Transport Force operator. I think I mentioned that, 130 ships moving across the Atlantic. But the pattern of handling big patterns was very, very important. I'll also connect that with you, the fact that I was born very cross-eyed. And I mentioned to you the other night about but they know why the cross-eyed. And not until but they said, don't, we must have full round eyes, they're very, very delicate. we have to wait till the child is 4, and then there's no chance the muscle will be strong enough to straighten the eyes out. And so at a little after 4, I was taken to the eye doctor for the first time. They found I was very, very far-sighted, and therefore I got my glasses. So I mentioned that to you the other day, that I really had two almost a second birth of seeing, a new set of seeing capabilities with such a high order compared with those first 3, which I also made clear to you the other day. That is a very, very big jump. And I'm sure that's had a lot to do with my life. At any rate, my father also died when I was very young, and I'm sure that had a lot to do with my life, because I was brought up then by my mother, and people who would give advice, and all these people saying, never mind what you think, really listen, this is the way the game goes, and I did everything I could to learn to play game, not to do my own thinking. So we have this moment when, after just a time of the death of the child, I was still in Armour coming in, and my father-in-law had invented a very interesting method of building. He was an architect, a very good architect. And I thought this ought to be, nobody's producing it, and I felt strongly about doing it. So a lot of my friends backed me going into this building business. And then I did get up, I did get 5 factories going in different parts of the United States in those years between 1922 and 1927, when the first child died and the second child was born. And I did get up 240 buildings. They were large residences, small and it might be a very large commercial garage or something, relatively small buildings, but 240 of them, and all through the eastern United States, nothing west of Mississippi, but gave me enormous experience in the building world. And I'd like to just talk about that for a minute. We are going a little late tonight, but I want to get in enough time, so I'm going to finish some of this particular thinking about why I did what I did, how I organized myself. In the building world, I found then, first place, this method of building we had was very attractive, absolutely novel, and I might as well tell you what it was. It was a method of making, first place I had to develop the manufacturing way to do it. We made fibrous blocks. And these fibrous blocks, I used wood excelsior. You've seen packing excelsior. And I had an enormous rotating machine and a shredder and so forth, and we covered it with a very evenly spreading on the fibers. It was sort of like pulling spaghetti out of a pile, throwing hay up with a hay fork, wetting each of these pieces with what they call magnesium oxychloride cement. And this we got all of it beautifully just wetted on the surface, and then I blew them together and felted them together in a mold. And they made a block form 16 inches long, 8 inches thick, and 4 inches high, with 2 4-inch holes on 8-inch centers, so that when you put a block to the other end, the next hole would be 8 inches away from the end hole of this block. And so the holes, as they were 4-inch holes, quite large in an 8-inch block. So there's about 2-inch wall between the hole and the outer side. These magnesium oxychloride treated fibers then firmed up, became very, 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 very rigid, and gradually they literally petrified. But a very interesting behavior was that they were very light. They weighed somewhere between 2.5 to 3 pounds each. They were so light and strong that, like a felt hat, you could throw them up to scaffolding to be laid. And they were laid end to end. And then we had, using wires, formed something like croquet wickets. A croquet wicket, but when you came to the foot, it went out just about 3/4 of an inch. And these croquet wickets were 12 inches this way, 16 inches this way, and 4 inches across the top of the wicket. 4 inches across the top of the wicket. These croquet, they would go down through the holes joining blocks, but you put them in upside down the other way, transversely of the wall, so that we had 4 wires, 2 going longitudinally in the wall and 2 crosswise like that. And they were put in, and then we mixed a very fine concrete with fine gravel and poured the column up to leaving 1 block open. We laid every time 4 courses, but you leave one course open, so that, excuse me, we laid 3 courses, and the wickets were 4 courses deep, and so they overlapped the course below. So the wickets then, we left the last top unpoured, so then we put 3 more blocks. The wicket from above would lap down into the one below before you poured, so that at the wickets overlapped each other, the wire 4 inches. I'd found that this is equivalent, the bond of it in the cement was equivalent to being continuous wire. So I had reinforcing in both inside the wall and longitudinally in the wall. And then we didn't, when we laid up the blocks, you didn't put any cement in between them. They just laid up dry. And then with the poured concrete, when we came to a window, we had girth blocks. We poured a beam to cap the columns. And then we had beams above the windows, and we had beams above the openings. And then every floor height, there's a continuous beam heading all the columns. This is another kind of pouring block. And we could lay these up so fast, you'd lay up a whole floor of a house in a day, sometimes a whole house in a day. And we put up, the cement is wet, so we had wooden bracings and so forth, so the wall would not move while it's setting up. Then when it was set up, we then plastered the inside, and we stuccoed the outside, so that this fibrous block became a beautiful bond for stucco or plaster, and the interior plaster and the exterior stucco were only united by completely flexible fibers, so the expansions and contractions inside and outside were very different, so the wall didn't tend to crack, tended to be a very beautiful wall, and we found that the blocks had they were equivalent to 4 inches of cork in their insulation value. And you could put blowtorch on it, and all it could do was just char away absolutely, just so as I said, gradually these blocks petrified. And I've been to some of the houses in recent years, and it's absolutely just pure stone fibers. So it was a beautiful fireproof, beautiful insulation, a wonderful bond for these plasters and so forth that you build very fast. And they were relatively low cost. And so my friends were excited by it, and we all thought they could make a lot of money by backing me. And my father-in-law was a prominent architect, and many architects, very great architects, thought it was very beautiful. And so it did get into a great many very special residences of very rich people, and they made very good houses. But when I then when the architect said, "I've got to use your material," and the owner said he liked it fine, I then would have to go around to the architect's office and show them how they designed their walls. I had to give that kind of service. Then came the time when the house was all designed, and the architect would then put the drawings out for bids to contractors. And the contractors see this, and they say, I can lay this up brick very easily, so I never saw this thing before, I'm just going to lose money on it, and so I know how to do this better. So they didn't like it at all. I would have to go out to, probably be 5 contractors bidding it. I'd have to go out to their place and go to the estimators, go over what it would cost, an extraordinary service I had to give them. And I had to practically promise the contractor I'd go out and lay it up for him when the time came, but to be sure that if he ever bid favorably. So sure enough, now we're going to build with it, all right, and the contractor's giving his bid. Then came problems with insurance companies, so I had to go to that. And then it came to problem, there was no code that allowed it in that town. There was not a town in America that would allow it. I would have to then, finding that it was a rather prominent client and an architect, they'd be able to get me somebody they knew in the town council, so they'd let me have a hearing in the town council to have to appear there. And then they would say, well, we'll give you a special permit provided you have tests made at our particular university. So I'd have to make up a test wall and let that cure, and we tested the university, and sure enough, it had the strength we said it had, and so finally came to to build, and so they gave me an order for 2-3 truckloads of this. It wasn't really worth very much. By this time, you'd used up any possible profit you could make, and an incredible overhead. So then I found that we got the job, and the carpenters said this is farm work, therefore it belongs to us. The mason said, obviously, these are blocks, this is masonry. So if the masons put it up, the carpenters went and pulled it down, and if the carpenters put it up, the masons pulled it down. And the lathers said, it's lath. So they didn't like it. So it was nothing but jurisdictional disputes. This used up more money. Anyway, out of the 240 buildings I was able to get up, I assure you that there was just nothing, I just couldn't make money. And when it was all over, and had to have special insurance, and had to have special, the banks didn't like it for mortgages and things. When it was all over, I had to start all over again. There was absolutely no momentum from the thing you'd done before. None. I said, this particular building world is just incredibly out of gear with the universe. And everything man has learned to do technologically is just, everything's backward here, and everybody doubts it, and the only thing that's any good is like your grandfather built that way, that's the way to build it. So that really taught me. After the 240 buildings, just about the time that our second child was born, I had really made a mess of this, and the company sold out the operation to a Celotex company who liked the material and my method of manufacturing, because I'm delivering by air and so forth. And you probably have seen in buildings, incidentally, because it looks so inflammable, this white, the oxychloride cement did not give the wood color. It just looked kind of wood. It looked like it's just any bale of packing of cells are going to burn up like that. So I used a carbon black powder, and it made it gray. It looked like concrete blocks. Anyway, the Celotex company bought it, and there's never been anything that's quite so good as sound absorbance. So there's a material called Soundex. You see many places where you see those fibers matted. That's the material I developed for that building. So I at least see my stuff around. Anyway, it sold out to Celotex, and I was really out, and I was penniless, and my friends did not think well of me, the people who at least tried to make money. A friend is a friend, so there was some friends left all right, but I was in anything but high repute as a businessman, and here was this new child. So I'll tell you, and I had been doing all this drinking and everything like that, and suddenly it was a totally new kind of life. And I really felt at that moment that I'd had really, by good luck of getting out of Harvard, I'd had an acceleration of experience. I really had much more experience than my contemporaries. And I, however, felt that I'd made such a mess of things that I didn't really like to try to make money anyway. I wanted to build a good wall. I'd like to make a good material. I really wasn't interested in the money side. And I was having to play very much of a game there, and was not good at that. And so I said I just quite clearly am a mess, and I thought then that maybe my mother was I say she was not well off. She was well off for just a single woman. And I said my wife's family and my mother might be able to take better care of my kids than my wife and my daughter. Maybe I better get myself. I just seemed to be a mess. I really felt tremendously messy, I assure you. And so I really contemplated very much suicide. Not contemplated, I actually started out to do so. And I got into then the thoughts about what is a human being? What are we? We're going to do away with this. What are you doing away with? I said, one thing I'll be doing away with is very great little experience. And I really learned an enormous amount with my experience, I assure you. And the fact that I didn't make money didn't mean that I hadn't learned my technology superbly. And I learned enormous patterns of how people get things done. And I've been through in getting those 5 factories going in 5 different cities, people putting up money, enormous amounts of legal work and patent work and so forth. Very familiar with those kinds of things. And I was very familiar with the business world's way of looking at things. So I said, well, each one of us is some kind of an inventory of experience. And I said, I do not really think that that we own ourselves, that we are here by virtue of others. And I said it could be that my experiences could be of value to humanity. So I said, there's only one condition for you not getting rid of you. As far as you for you goes, you've got to get rid of you for you. You can only entitled to stay alive if you really commit yourself and all your experiences to other human beings in a very, very complex, complete, out-and-out way. I told you how much impressed I was with principles, so that this idea precessionally of going off 90 degrees did not seem to be illogical to me. In fact, it seemed very logical, but it had never been tried, and so all my contemporaries are tied up with have to earn a living. And I said, I think this is just what we ought not to be doing. We ought to be saying, what do my experiences teach me needs to be done, which, if not done, will find world society in great trouble, which, if attended to, will find them in advantage. And what would I need to know in order, over above what I now know that made me see that that is so, what more would I need to know in order to be able to do something effective about it? I said, those are the kind of questions I thought we ought to be doing. And I then also came to ask myself a number of other questions. And I said, the only condition then of your saying is that you are committed to others, and number one, you have to do your own thinking. Everything that's happened to you really relates very much to your accepting other people's thinking, trying to play games that you didn't have your heart really in. So that this is going to be a very new kind of discipline. And you're going to have to be absolutely trustworthy that you really are committing yourself to other people. There's no cheating on this thing, not just this way you arrange not to kill yourself now, and then you're going to start cheating on this. You're going to have absolute conviction that you'll be able to carry through for your full lifetime. Well, I asked myself quite a number of things, and number one, I said, all right, you've experienced an enormous number of human beings who are deeply moved by their religions that they've been taught by their families. They belong to very large, great religions, have great fervor. And I said, all right, I've got the number one question you're going to have to ask yourself is, if you're going to do your own thinking and give up, this means giving up all belief. And I've been taught to believe various things, and I've accepted more or less wholeheartedly. I said, I'm going to have to give up all those things. I've got to start absolutely from experience, experiential base. So I said, do you have any personal experiences which give you reason to have to assume some greater intellect operating in the universe than that of man? I said, I'm just overwhelmed by the evidence of that. These generalized principles themselves, which can only be intellectually just detected, and they're utterly intellectual. They're weightless. A generalized case is absolutely intellectual. And there's an integrity. All these principles are all interaccommodative, so that I'm overwhelmed by an a priori greater intellect operative. I'm going to talk more about this on Friday, but I just want, that was very much one of the important questions right at the outset. So I said, then I'm going to assume that in doing my own thinking, I'm going to try to understand whether I am really, whether a great intellect thinks it is worthwhile for me to carry on. And what would be the requirements of a comprehensive integrity of our universe? Because it's looking out for all humanity, looking out for the universe. Why do we have these generalized principles? What is the universe itself trying to do? I said, I'm going to have to learn to ask myself some very big questions. I'm going to have to answer them myself from experience. Now, certainly, one little human being going to see what absolutely penniless, dependent wife and child, and trying to commit himself in such a big program as that, and everybody's saying you got to earn money. I assure you that my family and my wife's family and all of our friends I was being really very treacherous to do such a thing. And it was not easy to carry on, and there's nobody to tell you what to do, nobody to mark your paper. You had to really set out. You've got a commitment of how to solve problems by artifacts. And what are the first artifacts have to be done? Well, luckily there'd been that Navy experience. There'd been the doing more with less of the sea. There'd been the doing more, even more with less of the sky. And then getting in this building world where things are going absolutely opposite, and heavier and bigger and heavier and higher, the more secure. That's the way the people are thinking. I saw incredible ignorance that was dominant in that world. Therefore, the artifacts that have to be produced will be, how do you then give man such high performance? And I particularly have said I'm going to surround and give life, commit myself primarily to the young life, to the newborn where there are no conditioned reflexes. Trying to arrange the environment controls that will make it possible for that young life to be well protected, but to be able to get all the information it really needs, to be able to carry on in a very logical way to employ its brain. So coordinating feeling of its senses, information in its senses. So you can begin to see how the grand strategy began to shape up. Certainly, I said, I've heard people always trying to talk to other people, persuade them to do this and that. I must never from now on, I have so little time, if I ask people to listen to me, they're not going to listen, and your life will be gone. You must not talk to anybody unless they ask you to talk to them. I said that the other day, but that's a very fine principle. And you must not talk about your artifact that you think will work until you literally put it, designed it, actually made it, tested it, and find out whether it works. Then if it works, then if people say, what is that? Then I have an obligation to tell them what it is. And people then to ask me, then I must give them my best. I must not have just a short moment. We're now coming really to time to stop tonight, and I will have to say some more about the grand strategy in that moment, but I don't want to have to come back to that moment very much more. But I want you to understand why it really was enough to be a real turnaround. It had to be absolute turnaround. I've often said about friends of mine that I'm very, very fond of that been brought up with money and wealth and really charming human beings and very loving and lovable, and yet they get drinking and being wasting and so forth. And I often say if they really could if they could get in enough trouble to really hit bottom, then they might really get somewhere. But it is pretty difficult to get enough trouble just to do that, or not just to stay in trouble and so forth. And right, I think I represented that the world was in a state evolutionarily where certain things had to be done, and there'd be a Mr. X or Mr. Y would come along at a certain moment to do certain things. That I simply happened to fit into a Mr. X position, that I was and needed an average healthy human being and nothing else. He did not want genius, except that we're all genius. But somebody who could somehow rather be so committed that we then would be able to recapture the sensitivities we had. So I apparently just about qualified through getting enough mess to be Mr. X. But for all times there, you have to keep testing, and at my age, I'm sure you have to continually keep at myself about the disciplines to be sure that it is really out for everybody, and not getting a moment where you say it's sort of fun because a lot of friends, people come around and say I like you, this must not have anything to do with it. Absolutely, I think you really feel with me, being with me these few days, how much I really do feel then the outgo and the commitment to you, and I really feel quite badly when I'm being introduced and being made Mr. Big. And I have to deflate that just as rapidly as I can on the platform, because that's not the way I feel. I was deeply impressed, just reading my history, whether time and again such people as the Julius Caesar and so forth, beautiful Shakespeare's Julius Caesar and so forth, the individual who was really built some great roads and did make some very important advances for humanity in the counting systems and one way or another, then suddenly you're going Mr. Big. And yes, I'm something special. Therefore, I'm emperor. This is I'm something of God, and I'm something different. I said, you know enough of those things, so you not go in. If you do what you're doing, it's going to probably open up some very great treasures, but those don't belong to you. I've had conducted then a great many kind of projects, as you see, and I've done things to protect them as operations, but not as possessions. I would end this by this patent business, because I have this comes up from time to time, and I'd like to get it out of the way. I've taken a great many patents. I've taken them because here I was demonstrating what a little individual could do that great corporation couldn't do and great states couldn't do, but with great states and great corporations throwing the influence around very powerfully. As for instance, when I developed the geodesic domes, I had very extraordinary patents. The same patent attorney I told you who got me the patent on the projection, because the statement had been that it was pure invention. The same man then took out the geodesic patents. He wrote very good claims. Patents are only as good as the claims written by the patent attorney. And when the geodesic domes came into great need for the radar programs and many other of the government uses, but particularly radar programs, they're going to spend hundreds of millions of dollars on it. They found that I had already a structure. They tried everything else out, nothing else would work. And the president of MIT was a physicist in charge of the project of the getting ready the microwaves and the radar system for the early warning system, the DEWLINE, the Defense Early Warning System. And Wiesner then asked me to produce one of his domes, and I did, of my domes, and he did, and he put it around one of his radars. And if he hadn't done that, we just wouldn't have gotten anywhere. But anyway, they hadn't found anything else that did work, and when Wiesner bought my geodesic dome, polyester fiberglass dome, and put up around his radar up in the Lincoln Project roof, the MIT structural engineers then calculated, according to the most favorable analysis called Timchenko for spherical structures, and they found that this structure would disintegrate in a 14-mile-an-hour wind. So they advised the physicists they made a great mistake in acquiring this dome. And luckily, Hurricane Cal came along that year, 1953, and they had wind gusts up to 120 miles an hour, and it was just getting on fine. So the physicists called up the engineers, said, better look out then and see the sun, because it is not coming about at this very high winds. So the engineers said they obviously didn't understand it, so they needed to know more about it, so they moved that particular dome to the top of Mount Washington, where they have the highest winds in the United States. And no structures ever stayed on top of Mount Washington until they put that dome up. It stayed there for 2 years. The Air Force has a platform up. They would put structures in that stopwatch, see how many minutes before it blows away. Just regularly. And so suddenly the domes were in, and all the big corporations wanted to be in. So the Air Force has said, well, I had agreed that I didn't have any money, no capital to produce the dome, so I would license any reputable corporation. And so they said, you behave so well, we'll protect your patents too. So these, on their drawings that went out from the Air Force, they always had then to get the patent license from it. We had really the largest corporations in America all want to get in this program, so that my patent attorney would have the patent attorney of a great corporation coming to see him in New York. My patent attorney told me out of the over 100 patent attorneys from major corporations came to see him to talk about licenses, that at lunchtime or sometime during their day-long meeting, he'd say, you know, the first thing my clients had me do is try to get around your patent. The only reason I've come to you is because your claims are so well written. We had to take your license. Which is simply to say to you, if I had not taken out licenses and taken patents, you would never heard of me, because I only got really be known through the geodesic dome. And I knew I'd be absolutely steamrolled. I was working out, this was a big corporation, and any kids who wanted to get a license, I just gave them a license. but corporations had to really pay royalty. All those royalties got spent in more research and so forth. But I do want you to know why I've taken out patents. And I tell other kids, please don't spend your money because it's very, very expensive. I spent over $300,000 in patents to try to protect these things. I felt this is part of the responsibility of the job I am doing, and not a matter of possession. So we come to the end of today. Thank you.